A good day to everyone who's watching. In our lesson today, we're going to talk about indices. Now, indices, you can call them exponents, you can call them powers, and any other word that you can use to call them. If it is one, it is called an index. If there are many, we call them indices. Now, you remember when we prime decomposed numbers, for example, 8, and this one was 2 times 2 times 2 there, and then we wrote the 8 as 2 power 3. So the 3 is our index now, it's our power now, it's our exponent now. The 2 becomes now the base. Yeah. So remember that part where we prime decompose. This is what we used to do. So an index is a short form of writing a number, just like we had 2 times 2 3 times. So this is the 2 power 3 there. Then we are going to talk about some laws that govern us when we are dealing with the indices. So there we have some of the rows of indices. The most prominent ones are the first 3 there. Then the rest they come from these others, which are the first there. So the one that we had there, remember in primary, used to say multiplying numbers of the same base, you keep the base and then you add the power, which is that. For example, if I have 3 power 4, then times 3 power 2, that is, I'm going to keep the 3, then I add the powers 4 plus 2 there to have 3 power 6. Then dividing numbers of the same base, we subtract the powers. You keep the base, then you subtract the powers. That is, if I have 2 power 7, then divide by 2 power 5. So I'll be having 2, then I subtract the powers right there. So as to get the 2 power 2. Then now when I proceed with the third one there, is that when I have a number power, any power with any power, then outside the bracket there is another power. When I remove the bracket, those powers are going to be multiplying themselves. For example, if I have 4 squared, then I have a power 3 again outside the bracket. So if I remove the bracket, that is, the powers are going to multiply each other, and I end up having 4 power 6. Then when I go to the next one here, that if I have that power outside and I open it now here, that the power is going to distribute on each and every number that is inside the bracket. For example, if I have 2 times 3 and then power 4, so the 2 is going to have a power 4, then times also the 3 to have a power of 4, which is that there. Then this one here is just for division. It is the same thing, meaning the same thing, the power is distributed when you remove the bracket. It's the same thing if you have a division. For example, if I have 8 all over 7, then power 6 there, that one is going to be equal to 8 power 6 divided by 7 power 6. Now I go to the fifth one there. If I have any number raised to a negative power, is that when I want to simplify, I get the reciprocal of that number, but now the power becomes a positive. If I have 2 to the power negative 1, This one is the same as 1 all over 2 power positive 1 now, which is that. If I have this one, which are 2 numbers there, and then I'll take the reciprocal to have the power positive. If, for example, if I have 8 all over the 27 power negative 3, to make the power positive, that one's going to be 27 all over 8 power the 3 now. Then from there, you can go back now here, because at this stage it is now like this. Then you open the bracket, distributing the power on each and every, and then you continue with the simplification or whatever question it is. Then now, if I have a power to 1 all over n, that one is the nth root of that number. For example, if I have the root of 3 in index form, root of 3 is the 3 power a half. Now, this one here, if I have a power m all over n, this is the same as the nth root of a power m, or you can first take the nth root here, then you raise to the m there. For example, if I have 4 power 3 all over 2. So this one here, the 1 all over 2, the power 1 all over 2 there is going to be the root of 4. Then from there, I raise that answer to 3. Or someone can write that one as root of 4. Then so these ones here, they are just, it means the same here, just different ways of writing the same thing. So we can talk about also these common ones. A power 1 is the a. So any number, let me say 5 raised to 1 is that number. Any number power 1 is that number. Then any number power 0 is 1. So even if I have 1 billion or 1 million raised to 0, this one here is going to be a 1. So we have our examples there. Simplify the following, leaving your answers in index form. So part M, we see that there is a multiplication there of numbers of the same base. We have said we are going to keep the base, which is a 2. Then we add the powers. That is a 2. 5 plus the negative 7 plus 1. Then still the base. When I add there, I'm getting a negative 1. These 2 power negative 1. I want to make my power there positive. Then I take a reciprocal of this, of the 2. Remember, the 2 is all over 1. Then this reciprocal is 1 all over 2. Then power 1, just like that. So our part B, we have still the multiplication there. So you keep the base, then you add the powers, that is negative 5 plus negative 7, then plus a 1 there. So when I add there, this is negative 12 plus 1, it becomes negative 11. So I have 3 power negative 11, making the power positive. I take the reciprocal, 1 all over 3 power 11. So our part C, we have the multiplication in the numerator and the multiplication in the denominator. Then we also have a division there. So in the numerator, keeping the base, adding the powers. Then also in the denominator, keeping the base, adding the powers. So this one here, I have x power. What do I have here? Is a positive 2. Then divide by x here I'm having a negative 4 when I add. Then now I'm having two numbers of the same base, and they are dividing each other. So I keep the base, then I subtract the powers. That is 2 minus the negative 4. And that one I have x power. That one there is going to become a positive. And then when I add, I have a 6. So the part D there, we have also the numerator being a multiplication, denominator also being a multiplication, and the over is the division sign there. But let us first simplify the numerator and denominator. So the numbers that you see here that don't possess powers, you recall the other law that a power 1 is the a. So now you are having a, but it means that that a is having a power 1. So these 3, which doesn't have a power, and the 2, they are all having now powers of 1. So this is going to be 2 power. There is no 2 here in the numerator. I keep that. So 3 power. There is a 2. I add a 1. I add, even this one here has a 1. Divide by 3 squared, then times 2 power 4 plus 1. I'm adding this one, there is a power of 1. Then in the numerator, that is 2 power 2, then times 3. When I add there, that's going to be power 4. Divide by this one here, 3 squared, then times 2. That one there is power 5. Now, I'm having numbers dividing each other of the same base, even that one there. So I have 2 power 2 minus 5, then times a 3 power 4 minus a 2. So this one here, I'm having 2 power, that one there, when I subtract negative 3, then times 3 power a 2. Now this 2 power negative 3, I can take it in the numerator to have here 2 power 3 power 2 all over 2 power 3. So we have our example to simplify the following. Our part A there, we have the 0.125 power 2 all over 3. Now there is a tendency of students writing wrongly the power A. For example, if I have 2 power maybe 6, this student writes it like 2 power. I think there is a difference there. Some end up writing it on the same. You can't even realize that this one here is the power. They are writing it on the same line and giving it the same size, but the power should be slightly above that number. So I'm going to first rewrite the number inside the bracket as 125 all over 1000 now, power 2 all over 3. Then next is that, because I'm seeing the 1 all over 3 or the 2 all over 3 or the third in there, in that power, I'm going to prime decompose 125. Then I prime decompose 1000. If you don't know how to prime decompose, please, I beg you go back to one of the videos under the numbers, then you watch how we prime decompose. So prime decomposing this one is 5 cubed all over 10 cubed, then power 2 all over 3. Now I'm going to open the brackets. When we open the brackets, the power is going to distribute in the numerator and the denominator. So that is 5 power 3, then times 2 all over 3 all over 10 power 2 times 2 all over 3. So when I compute that there, I'll be having 5 power 2, then all over 10 power 2. So I can leave my answer like this, or I can say this is 25 all over 100. The question is just simplify. If it was evaluate, that you need to square this one and that one there, get the 25 all over 100. But if they said simplify, you can leave the answer here or there. So my part be there. The powers there, they are in mixed fraction. So I'm going to first convert them into the improper fraction. So this is 100. When I convert 2 times 1 is a 2 plus 1, that is a 3 all over. Then times the 4 minus 3 all over 2. Then now this 100 here is the same as 10 squared. So the power outside there, I'm creating the brackets because the 100 is now becoming 10 squared. Then times 2 squared power negative 3 all over 2. Then now I remove the bracket. This is 10 power 2 times 3 all over 2. Then times 2 with the square there times the negative 3 all over 2. When I compute this here, I'm having a power of 3, 10 to power 3, then times 2 to power a negative 3. Now, if I've been told to simplify, now I'm still simplifying. This 2 can go in the denominator by making its power positive, like that. Hope you remember. This 10 is all over 1. So what I get here is the 10 power 3 all over 2 power 3. I can still simplify there. Using the law that a all over b power n is the same as a power n all over b power n. Now I'm having this there. That's the 10 power 3, 2 power 3. The power is the same. I can take them back here. That is going to be now the 10 all over 2 power 3. Then now I can divide this one here. So I get now the answer as 5 power 3, just like that. Our part C, I have the 4 there. It's going to be the 2 squared. The A has the base number here, the A here, then also the B there. So I'm going to have the 2 squared times the A cubed, then minus 4, then times the 3, then times the B power 2, then minus 1. This B here has a minus 1. Then divide by 2 power 2 plus 2. We have these two, the bases here. So I'm adding their powers. So what I get here, that is 2 squared, then times A power negative 1, then times 3, then times B power 1 all over the 2 power 4 there. So that's going to be the 2. The bases are the same. I'm subtracting the powers. Then times the A power negative 1 times the B power 1, then times the 3 power 1, then times the B power 1. So this one here, when I subtract, this is 2 power negative 2 times A power negative 1 times B power 1 times 3 power 1 times B power 1. Then I can take this having negative in the denominator. So that's going to be 3B all over 2 squared, then times A power 1. These ones also, they are raised to 1. 81 all over the 16 power a half. So the 81 is the same as 9 squared, and also the 16 is the same as 4 squared, then power a half. Now when I open the brackets, that's going to be 9 squared, then times a half, all over 4 squared, then times a half. So when I compute that, I'm having a 9 all over. When I compute that, I'm having a 4. Now, this one here is the same as someone who first decomposes 81 and 16. When you prime decompose 81, that's 3 power 4. All over 16 is the 2, also power 4. Then power the half there. Then you remove the brackets. The power is going to distribute on the base of the numerator and the base of the denominator. So computing this is 3 power 2 all over. Computing that is 2 power 2, which goes back to 9 all over the 4. So our example 3 there, evaluate the following. Part A is right there and part B. So our part A there, I'm going to first make my powers there positive. This is going to be when I take now the reciprocal. That's 1, 2, 5 all over 8 power. This now becomes positive 2 all over 3. Then times, that is 8 power a half all over 5 power positive 2. I can now prime decompose the 1 to 5 and the 8, even the 8 there. So when I prime decompose this, it is 5 power 3 all over 2 power 3. Then the outside power is 2 all over 3. Then times this one here is 2 power 3 all over 5 power 1. Outside there is a power of 2. Now, when I open the brackets, we have said the power is going to multiply the power here and the power there. So this is going to be 5 power 3 times 2 all over 3, and then all over the 2 power 3 times 2 all over 3. Then there is also a multiplication there of the 2 power 3 times 2 all over 5 power 2. So I simplify that. That's going to be 5 power 2 all over 2. When I simplify that, it's going to be a power 2. Then times, this is 2 power 6 all over 5 power 2. Now, I'm having numbers of the same base dividing each other, even this one here. So that's going to be the 2 power 6 minus a 2, then all over 5, 2 minus a 2. So it's the same way. I can also take this and I subtract it with the value down there. So this one here is going to be the 2 power a 4 all over 5 power 0. We say any number power 0 is a 1, and then 2 power 4 becomes a 16. They told us to evaluate. They need the actual value, which is that one there. So our part B, we are also going to prime decompose those figures there. They are not the same, but we need to prime decompose them. 12 is the same as when you prime decompose 12. Someone can say it is 4 times 3, but when you prime decompose that, it's 2 squared, then times 3 power 1. That's the 12. The 27, prime decomposing 3, 2. The 18, has a 9 there, and the 2 to power 1 times the 9, which is 3 squared. We're going to substitute them there, and then the 16 is also the 2 power 4. So this one here, the 12 is going to be equal to 2 times 3, 2 squared. Then there is a power of 3 all over 2 times 2 power 4. Then there is a power of 1 all over 8. Divide by 3 cubed. Then there is a power of 1 all over 6. Then times the 18, which is 2 times 3 squared. Then there is a power of a half. So what do I have next? I'm going to open the brackets. So the 2 squared, then times 3 all over 2, then times the 3 there, power 3 all over 2, then times the 2 there, power 4 times 1 all over 8, all over this one here, 3 power 3 times 6, all of times 2 power a half, then times 3 power 2 times a half. So when I compute that, I'm having 2 power 3, because the 2 cancels, then times 3 power 3 all over 2, then times the 2. When I compute this, it becomes power a half, all over 3 power a half, then times 2 power a half, then times the 3 there, power a 1. Now when you look at 2 power a half and 2 power a half there, they can cancel out. So I'll be having 2 power 3, then times 3 power 3 all over 2, then all over the 3 down. I'm having 2 of them. I'm going to add their powers. So that is 1 plus a half. Fractions, addition of fractions, I think you still remember them. If you don't remember, please you go and see how we added the fractions. So this is going to be 2 power 3 times the 3 power 3 all over 2 divided by the 3 power 3 all over 2. And then this 3 all over 2 is the same as the 3 all over 2 in the numerator. So I remain with the 2 power 3, which is now the 8.